Hi, welcome to Woo.dev, and in this tutorial I'll be covering the most basic things around working with APIs as a front-end developer, covering fetch API, async await, try catch, and everything around those really confusing definitions that may be difficult for everyone to understand in their beginnings. So let's jump into it. So API stands for Application Programming Interface, and in very simplistic terms, it means the set of rules and tools that you can use to communicate between one application and the other, or many more. In web development, API are set of rules and tools that you can use to interact between the client side, which is the browser, and the backend, which is the server. Typically, when we hear API as front-end developers, we think about REST APIs, and REST API is a specific architecture of API that allows our browser to communicate with our backend in a RESTful way. We are not going to dig into the specific of what REST means, but it is a specific architecture of creating your API on the backend, plus using it and communicating with that backend server from the client itself. So in this diagram, you can see that we have two sides that need to communicate with each other. So as we said, client side is called browser, and the backend side is our server. In a typical flow of web development, your user wants to fetch data, for example, on the click, and they want their action to display some dynamic data. Now, as we see, once the user clicks fetch data, the browser sends a request, which is a specific definition of that workflow, to our backend endpoint. Now, endpoint is a specific URL that is created by backend developers that represents some kind of interaction, some kind of action that our client-side logic can do. Meaning we can fetch data, we can update data, we can delete data from the server specifically once we hit that endpoint. And by hit, we mean sending our request from the browser to this specific URL. And we are not responsible for creating those endpoints. Those are responsibilities of backend developers. What we need to know is how they look like and what kind of interactions we can do with them in order to get some kind of response from that backend application. So as we can see, once the specific type of request hits this endpoint, let's say it's called domain backend.com/getData, it automatically sends the response. It doesn't have to be a successful one. It can be also unsuccessful one. But this response allows us to either get the data that we want and put it dynamically into our application, or we can get informed about whether our action was successful or not. Our browser request to the backend side can be of many types. It can be a type of get, post, put, patch, or delete. It can be many other types, but those are the main ones. And their types correspond to what kind of action we want to do with our data, whether it's fetching the data or updating the data on the server itself. So, for example, get request, which is one of the most basic ones, it means that when we are sending a get request, it means we would like to get some piece of data that is represented through the endpoint on the backend side. Now, if you would like to update some piece of data, let's say we would like to add a new user to our server, we need to run a post request. And obviously, if we would like to delete some piece of data, we need to send a delete request to our backend side application. Now, what we need to know is not only the types of request, but also statuses of the response. So when we are thinking about writing a request to our backend side, we mainly need to know two things: whether the endpoint is there and what kind of endpoint it is, plus what kind of request it needs to be that is associated with that endpoint. Now, when we get the response from the server, we have the information that we want to have, or we have the information of whether our request was successful or not. So every single backend response can send us some kind of a HTTP status, because REST API is based on HTTP protocol. So for example, you may find it on different websites. For example, if you, let's say, go into a website that the page that you are trying to find is not found, you see 404. That is an HTTP status code, which is basically a backend response of the API saying, I cannot find it. Also, if a successful request is done and we have, let's say, a piece of data fetched to our client or a piece of data updated successfully on the server, we get a 200 or 201 response. So basically every single HTTP status code that starts with 2 means it's successful, and if it starts with 4, it means that it's unsuccessful. We also have status codes that start with 3 or 5 or 1, but those are not as common especially when we are starting to work with the APIs themselves. So if we, let's say, go to a GET request documentation for get all posts, as we can see, we have an endpoint that is created for us. It's localhost 3000/post. So every single REST API endpoint will have the backend domain. In our case, it's localhost, but in the production environment, that would be basically your own domain of the website / some kind of appendix to your endpoint that represents some kind of action or place in the server that you can run your action from or to. So if we hit localhost 3000/posts and we click send request, we automatically get list of posts. So as you can see, it's an array of objects. So every single object represents one post. It has an ID, title, tags, author ID, and so on. Additionally, if we go to the headers tag, we can see that with our request, we are sending a header, so a piece of data that allows the backend application to understand what kind of content we would like to fetch and other details that are needed when we are communicating with our backend API. And in our case, this is content type, that is application/JSON. So this is very important. So when it comes to REST API, the entire communication is based on JSON objects, which mean that whenever we are trying to fetch some data or update some data by sending the data from the client to the server, they need to be within a JSON format. So it's like an object that JavaScript is able to see and manipulate, and the same thing goes for our backend application. So the GET request is basic because the only thing that we need to do is just send the request and we are getting the data. But what about the POST request? So as you can see, the endpoint is the same, but because we are on our front end, we are just basically changing the type of the request to POST. We automatically have to not only send the request, but also send something with the request. So as you can see inside our body, we are sending a new post that we would like to update on the server. So we're adding new title, new author ID, new tags, and everything else. And once we send that, we are automatically getting 201 status, which means for the post request, it is successful. And additionally, it returns, so the response of the post request also contains the actual content of our new post. So now if we once again fetch all posts and we send the request, as you can see, we have 200 OK status because GET requests, once they are successful, they are 200 and not 201. If we scroll down, we see our new post. So the fourth post that was now added to our server can be fetched through our GET request of localhost 3000/posts. And finally, if we would like to delete that post, the post that we have just added, we can run localhost 3000/post/4, which is a dynamic number that represents the ID of the post. And the only thing additional that we need to do is basically assign this request as a delete request. So if we send this, we once again get a 200 status, which doesn't return anything, but we can check whether it actually worked if we once again resend our request. And as you can see now, all of our posts on the server are the posts that we had before our initial update, which are basically free posts. Okay, so now let's jump into the code itself. As you can see, we have a very simple HTML file with body, with main, and one button with ID of fetch data, with fetch, which basically means that the button that we will use will be fetching our piece of data from our backend. And also we have a, for now, empty section that has an ID of results. So in the upcoming future, we'll be appending the results of our API into this section. Additionally, I appended our api.js file that is beneath this file. And here we'll be able to actually write the logic to allow us to communicate with this backend server. So the main tool for us front-end developers to communicate with specific backend API endpoints is fetch. Now, fetch is basically a native for JavaScript function that allows us to add the endpoint of our backend API. So in our case, it's called localhost 3000/posts. And because fetch API, the fetch function itself, returns a promise, so we are not going to dive into the promises themselves right now, but what it basically means that we can run some methods on this fetch function that allow us to manipulate and do something with the data that might be coming from this specific endpoint. So now, if we append a then method to our fetch function, and we would like to console log it like this, and let's save it. Now, if we go to our console, we can see that we are getting a response which has plenty of different details like OK, true, status to 100, which is good because now we can see that our communication was successful. So now, in order to actually see the data that we would like to see and not the details around this specific request, what we need to change is that, first of all, we would like to reformat our data into a JSON object. And once again, we would like to console log our data into our console. And now, as you can see, we have an array of 3 different objects, so 3 different posts. So this is the most basic approach to running a fetch function. Now, let's quickly make sure that this fetch function runs on a click. So we will be working with document query selectors. So let's query select our button, which has an ID of fetch data. And let's add an event listener to our button. And let's move our fetch function into the event listener. So now, if you once again console log everything, we can see that the data is flowing only on the click. Now, the first hint that I would like to showcase is that it is very important that when we are working with APIs, we need to make sure that all of the pieces that create our logic are readable and understandable. So as you can see, I did a weird thing. I created 2 lines of code that are very similar, but they represent a totally different action. So as you can see, I first fetched data that I transferred into a JSON object, and then once again, I used this data to console log it out. But the better approach would be to name it differently, just to understand what we are dealing with. So first of all, I would prefer to change it into response, because first of all, when we are communicating with a backend endpoint, we are first getting a response, and then we are responsible for reformatting this response into JSON, and then we are actually getting the data that we would like to do something with. Additionally, as you can see, our fetch function as the first argument has our backend endpoint, but we are going to make many more of those. So the best approach would be to actually create an variable that allows us to store all of our backend endpoints in one place. So let's say that this is a GET request endpoint. So I would prefer to create an object called GET and assign it to get.posts variable. So in our case, this would be just that. So we are creating a GET object with a key of posts, and it allows us to now basically change this into get.post. And now it is much more readable because first of all, we know that we are running a GET request that is associated with posts, and every single line that comes after that is understandable, what we are doing with what kind of information. Now, what we would like to extend is that we wouldn't like to see the data that is coming from the backend in our console because that makes no sense, but rather append it to our section with ID results. So now let's make a results section available for us in JavaScript. So once again, we can do that with a query selector. And now, instead of console log data, we'll be working with data for each. And every single post that we would like to showcase should be inserted into a new element in our website. So first of all, let's create that element. So const element, document, create element, div, and the element text content should be equal to post.title. And now the only thing we need to do is append those children, those elements into our results section. So we can do it by results, append child, element. Now let's see how it looks like once you click fetch. Yes, we are seeing all of those titles coming from our backend. So that's good. And every single time we click fetch, we are appending and extending the list of our posts. Now, just for the sake of this UI looking quite good, we can, before we are looping through all of those posts coming from our backend response, we can clear out the content of the results element by results inner HTML is equal to null. And now, as you can see, once I click fetch, we are only getting the posts that are coming from the backend, and they are overwriting everything that was there before. So another hint that I would personally recommend is that we shouldn't think about communicating with backend APIs as just basically getting some data or updating some data, but we need to think about it from the user perspective. So in our case, we have our backend really fast, it is local, so nothing happens to it, and we are 100% sure that we are using correct endpoints. But what happens, first of all, if our network is really slow? What we could do is we could, once again, inspect our browser, go to network, and inside this small toggle, we could change and throttle our internet connection to 3G. So, as you can see now, if I do so, and once again click fetch, it takes long time to actually get this piece of data, and the user is not able to understand what's going on. So what they could do actually is that they could actually be scared that what they did was unsuccessful, and the user could actually refetch it multiple times by clicking fetch. But as you can see, that makes our network run it really frequently. So there are many ways that we could prevent that from happening. So first of all, what we could do is basically increase the UX by making sure that our fetch button changes its content to, let's say, loading. So we could do that with running a button text content equals to loading. So whenever we are fetching the piece of data, it changes to loading. And we can also add a new method to our fetch, which is called finally, which is basically executed whenever everything that we do finalizes. And we can append a function inside of that, and we can make sure that our button text content is back to fetch. So now with 3G throttled, we can click fetch, and as you can see, it's loading. And once we get the response from the backend API, we can actually see the results and our button is changed to fetch. So that's another hint. Always make sure that the user understands what's going on, especially when your backend might be slow. We are responsible for creating a user-friendly UI. Additionally, what may happen is that, let's say our backend doesn't work, or we have inserted a wrong endpoint. So let's say that we would like to change our endpoint into posts double S. And now if I save, we can actually see, but first let me maybe dethrottle everything so it's much faster. If I run fetch, we can see that nothing happened, even though we could see the loading state for some second, but inside of our console, we have an error that data.forEach is not a function plus 404 not found. So what it means is that, as you may understand, this endpoint is not found. The backend that was created doesn't have this resource available for us, and it doesn't do anything. And because of that, all of our pieces of code also doesn't work. So if the data is undefined, it means that for each is not a function, because undefined cannot be used with for each. So now we are getting into a very important hint, which is think about errors first. And in order to do so, what you can do is you can attach a catch method that allows you to catch the errors that are coming through this communication. So if we run catch and we, let's say, console error dot message, and we save, and we go back to our console, and we click fetch, it basically once again returns this error. But because we are using catch, it doesn't mean that it prevents our fetch API to stop whenever it has some kind of a failure. In order to prevent that, we need to do additional thing. In order to prevent the second then from basically running, we could actually first, before we are reformatting our response to JSON, we could check whether our response is fine. So if we check if response is not okay, then we are throwing manually our own error, which will be, let's say, called something went wrong with our response. And if this is not true, meaning that the response is okay, we are basically returning our response back to JSON. That means that if we throw the error in this particular point, we are preventing this data and this entire then method to run, and we automatically, by throwing the error, we are catching this error in this particular message. So now if we click fetch once again, you see that we have 404 not found, which is fine, but also we are not seeing any problem with data being looped, because we are preventing this then method to actually being run, and we are catching the error that we basically created with something went wrong with our response. So this is much better. Additionally, apart from console logging this just for the sake of development, we could actually make sure that our user knows that something went wrong, and then they can try to refetch, for example. We could do it by, let's say, saying that the content of our result should be the error itself, actually. So we can use the error message as a content of the results. So if we now fetch, you see now our results only contain something went wrong with our response. And now, if we reload, everything is fine again. So this is good. So now all of the errors will be shown to the user whenever they happen, so that's good. But what happens if our internet or backend API is very slow once again, and we throttle our network to 3G? We once again see that once we load the data, nothing is happening. And still, the user might be tempted to basically re-click every single time they don't see the results in a split of a second. Now, this is a very important thing, because if the user decides to run the post API again and again, it is causing our browser to hit our backend API with multiple requests that are identical. This doesn't sound like something really bad, but if we do it frequently and there are many endpoints that we need to hit, it doesn't allow the backend to work performantly, and it might result in what is called race conditions. So in order to prevent the user to re-request and run those multiple requests one by one, what we could do is that whenever we are waiting for the data to be sent to our user, and the user decides to rerun the request, we cancel the previous request. So in order to cancel a already ongoing request, we could use something that is also native, the same way that fetch is, to JavaScript, that is called AbortController. And in order to do that, we first need to make sure that our fetch function is inside some kind of a function itself. So let's create a function called fetch posts. And let's bring all of those pieces here. And now, in order to make sure that our abort controller basically aborts any ongoing request, we need to create one. First, we need to create a variable called controller. Now, inside our fetch post, we need to assign this controller to a new abort controller, which then should be assigned to our fetch function. We can do it by adding a second argument, which needs to be in curly brackets, and inside a signal, we can assign it to controller.signal, which means that this abort controller is now basically watching our fetch running. And now, as you can see, inside my click function, I added if the controller exists on the click, meaning that if once again something is clicked and the controller is ongoing, so the signal is there, we are aborting. We are running a controller.abort. We are additionally console.erroring something saying ongoing request aborted, rerunning, and we once again rerun our fetch post function. So now if we click and we see our network tab, if we click fetch, the first fetch, let's wait for that. Yeah, it works. But now let's say that I am not happy with how slow it is. If I am a really stubborn user, as you can see, if I click it multiple times, every single time I re-click it while waiting for the data, this is canceled. So for our API and for the server itself, this is much better and much more performant because we are making sure that nothing is being resent more than once. So as a last part of our video, we'll be basically reformatting this piece of fetch function into something that is much more readable and is also I would say, not only mine, but also everybody's recommendation to use, which is async await, that also is sometimes really difficult to understand at the beginning. So as we said in the beginning, the fetch function itself returns a promise. And because a function returns a promise, we can run methods on an asynchronous function that returns promises, which are .then, .catch, and .finally. But with one of the new ECMAScript releases, we are able to make our asynchronous code much more readable and make it look something similar to asynchronous code. In order to do that, we need to first mark our fetch function as async, which means this function is asynchronous. And now we need to basically write our fetch API function and fetch API logic synchronously with a wait keyword. So first of all, we would like to get a response the same way as we did with this .then. So we are saying const response, await fetch, and let's copy the content from here to here. So this basically means that this line is equal to almost this .then, because now we need to once again synchronously, line by line, do the same thing. So if the response is not okay, we are throwing in the error, and if not, we are now able to work with our response JSON. But we should not return it because we are not working with a callback functions anymore, but we should be assigning this to data, and we should await this, once again, this method of reformatting the response into JSON. So I believe we can actually delete this piece. Now, what we could do is basically copy the content of this piece here, and also delete this piece once again. And now we are left with .catch and .finally. And now something that is also related with async await is a try catch block. So try catch block is an answer that came with async await that was basically an equivalent of catch and finally. So what we could do with try catch, we can create one inside our VS Code by writing try catch and clicking tab button. And inside our try block, we should basically add pieces of logic that should be optimistic, meaning this is the main logic that I would like to use and let's say get some data out of that. So we can basically get all of those pieces of data here. And the catch block is the same thing as .catch. So whenever something happens, so for example, if the response is not okay and we are throwing the error, we can catch this error and do something with it. So inside our catch block, we are basically copying and pasting this piece of content. And the same thing happens with finally. We can also add what's called a finally block. And we can do the same here. So now our fetch post function is much more readable because everything is done line by line. There are no .then, there are no .catches, and there are no .finallys. Everything is within its own block, and every single line is done which looks as if it was synchronous. So if we rerun and maybe let's turn our internet up in its speed, if we click fetch, everything looks the same way. And as you can see, the abort controller works the same. It didn't affect any piece of our code. It's just basically a syntax difference. So now the last thing for us is to actually do the same thing, but for the post request. Just for a reminder, when we are running a post request, we typically do that in order to update and add a new piece of data into our backend. And as you can see, in order to do so, not only do we have to run a post request into a specific endpoint, but we also have to send a body with this request. And we can do that with our fetch API as well. So as you can see, Postman API tells us that in order to add a new post, we need to add this piece of body with the request. Most likely, if we just add just a piece of it, so for example, title and content, we can actually test that, we can send, and we have 201 created. So we are actually able to send a smaller body with just title and content. So let's do that for our posts. So here I added a really simple form with a label and input for new post title and a label and input for the content of the post. And now we are able to actually use those in order to communicate with our backend via post requests. So first of all, we need to get those inputs from the document itself. So let's name it post text input. And also post content input. And additionally, I would also add a button just for submitting the form. So input type, not input, but button type button with a name of, let's say, add new post. And I would also add the ID of add new or add post button. And now I can make it visible for my JavaScript with add post button ID query selector. And now let's create a new function, which will also be asynchronous, and we will now stay with the async await syntax. Let's call it async functions add new post. And this function has to get two pieces of data. So it will get title and the content. So let's add those as the parameters. And now let's do a similar thing. So let's start with try catch. Let's first get the response by awaiting fetch with our endpoint. Now, as you can see, if we go back to Postman, this is the same endpoint. However, I would like to create a new object that is only there to represent endpoint that is used for post request. So even though this is the same as the previous one. I would rather have it in a separate place. Additionally, I would also make it more readable. So instead of post.post, I would say new post, for example. So now if we scroll back to our fetch function, we can go post.new post. And now when the fetch function only has one argument, which is the endpoint itself, it automatically, as a default, runs a GET request. So in order to change it to a POST request, we need to, inside our curly brackets as a second argument, we need to add method that is equal to POST. And now, as we may recall, we also have to add the body. So we need to allow our request to send the body of our new title and content to our backend. So we need to create body. And as we also discussed, the communication is based on JSON. But because this is JavaScript, we need to also reformat the same way as we are getting our data by reformatting the response with .json. Here we need to do JSON stringify. And now we can basically write title and content. Additionally, for the post request, I would also prefer to add the headers themselves. So as you can see, Postman recommends to add this specific header. So we can actually do headers, and we can run content type application JSON. Now, our basic fetch post request is there. Now, once again, if our response is not okay, we should throw an error saying, and now we can also make it more dynamic. So for example, we can open our template literals and say new post was not added successfully. Response responded with, and now we can use the response.status. But if everything is okay, we can now await the data with, once again, response.json. And now, because we don't have to do anything to display this piece of data, because we are basically running the update on the server, we can basically run console, maybe info. Once again, let's open template literal and say new post added with data. And now we can add the data here as well. Now, if we catch an error, we can do console.error with the error.message. So now we can append an event listener for this add new post click. So if we go add post button, add event listener click, we can add a function that will call our add new post. And we can get the values of whatever is inside the input of those new post title and new post content. So just quickly checking what kind of post text input and post context input. So post text input dot value and post content input dot value. And now, if we now fetch, we can see that we only have those 3 default posts inside the database. But if we now quickly open the console and we do new post and new post content, and we click add new post, we see that now we have new post added with data. Let's reformat it in a second. But now once we click fetch, we have the 4th new post appended and added to the database. So the newest fetch will actually get this piece of data, and this is saved, and we can use it anywhere you want once we call our endpoint with a GET request. Now, just for the sake of the console log being readable, we can go with data title, data content, and let's check if that changes anything. So now if I add new post 2 and new content 2, we have new post 2, new content 2, and once again, if we go fetch, now we have all of that once again available for us with the newest fetch. So this is how you run GET and POST requests with a standard fetch API. So recalling every single hint and recommendation that we've talked about is that whenever we create the placeholder for our endpoint URLs, we should make them as readable and as accessible as possible, meaning they should be in one place. In order for our user not to re-request heavily after, let's say, multiple clicks, we should always use some kind of tools like new AbortController that cancels any ongoing request once the request is redone. Additionally, we need to use try-catch with async await just for the sake of our code being more readable and looking as if it was synchronous. And additionally, we need to make sure that line by line, everything is described the way that it represents the reality. So we need to name our variables and our promises the way that they should be described properly. Additionally, we need to make sure that we are thinking about the user. So we shouldn't be thinking about how the page looks when everything is successful, but we should think about how things may go wrong if they do go wrong. So this is one of the most difficult parts, but one of the most important ones when we are dealing with APIs. So let's think about errors more than we think about positive results. And let's use finally blocks as much as possible in order to make the UI more user-friendly and to clear everything that was an ongoing process once the API was called. For the post method, always remember that you use JSON stringify to make sure that whatever you are passing inside a body of the request is in JSON, and that we use headers because they are also important from the backend application standpoint. Always make sure that all of the errors that you are using are thrown so we can actually cancel everything that is after the error and we can catch it properly within our catch block. In the upcoming videos, I'll be covering promises and I'll be covering more intermediate and advanced ways to even more enhance your workflow with APIs with Axios, Zod, React, and TypeScript, just for the sake of us working with APIs more performantly and more cleanly. So that was it for today. So thank you very much for watching. And if you enjoyed the video, don't forget to subscribe to the channel, like the video, and I'll see you in the next one.